Yeah, thank you so much for giving me this big stage here in my hometown, Aachen. My name is Tobias Augspurger. I am the lead of electrical grid mapping at Open Energy Transition since the beginning of the year. So this is also for me something brand new. My background is actually more in atmospheric physics, sustainability, Earth observation, and let's say more data-driven parts. And I've now found, let's say, a way into the energy transition, especially into open energy transition. That's the company I'm working for. It's actually a German company that I would just like to introduce at first. So what do we do at Open Energy Transition? So the main, let's say, goal that we are looking into is to make software for energy planning so that we have better decisions on complex energy systems. So sometimes if you look into newspapers, it feels like that energy systems is something that people just decide on their political opinion and other, let's say, ideas they have. But to make it really professional and not opinionated by some political parties, we create software so that you can use open data to make something that is traceable so that you can get into a conversation about why do we plan these energy systems in this way and how does a good energy system for this planet actually look like. And what we do there is we look into how to operate your energy system, but also how to invest into your energy systems, how to regulate it, but also how to innovate it. So we will talk about all of this also today. What you see in the background is actually the global transmission grid network from Open Infrastructure Map using actually OpenStreetMap data. It's actually created this image by Russ Garrett. So what and why open source software for energy system planning? So you might already using a lot of proprietary software. You might also use some open source software. And we can look into why you're doing proprietary software. So at first, it looks like, yeah, it's really frictionless. You get started very soon. It fulfills all your needs. It has good support. And it's widely known because they do a lot of marketing. That is what their companies are really good in. What they're not so good in is to customize your solution. So if you want something special to do, you have a really hard job. Also, if you want to collaborate with someone else on such a development, that's pretty hard. He also needs such a license, and such licenses sometimes cost you for one developer more than 100,000 euros. And it's also about just transparency and traceability in what you're doing. Because those models are closed, they might tell you how the software works, but they will never show you actually the details in how this has been solved. So you're always working with a black box. That makes it very, let's say, easy to manipulate results. You can actually not really discuss about how such a model or such a proprietary software really works in its core. And it's also about digital sovereignty, because at the end, you can just get lost in this frameworks. You cannot really switch to another framework because they try everything to keep you trapped in what they are doing with proprietary data standards, with everything they do is more or less to keep you tracked and always keep you with this kind of software so that you always have to pay more than $100,000 per year per seat. And it's also that you, on the long term, you just get in a lot of dependencies on those vendors. So that's why proprietary software is a little bit problematic. And our vision is really to push open source software as a standard for energy planning until 2028. And we do this by doing a lot of institutional pilots and credibility building. Because as you might know, open source has always, and open data is always the problem, if it doesn't cost you money to acquire this product, it cannot be worth a lot, right? So the more you pay, the more you think actually this is actually of quality, but this doesn't work for open source. But a lot of people think that. We also want to create a whole, let's say, tooling ecosystem for the whole space. So where to combine a lot of existing tooling, that's the main purpose. We use data and more data infrastructure. So it's really about also providing you the right data for your use case. And it's about adaptation and enablement so that you can adapt it to your own personal needs, all those products. So we are quite a fresh German company, actually a non-profit, funded by Max Parzen. And we are now 50 people, half of them with a PhD, all remote, scattered all around the globe. So we have people from Africa, from South America, we have people from the US, from Asia. We don't have at the moment people from Australia, I must say. So if you are interested, that would be good. We really focus 100% on open source and open data. So this is really at the core of our company. So we will try to open up as much as possible what can be done also with our clients. And we always try to feed back actually into original open source products to really support the ecosystem. So we are not actually, our idea is not to own open source products, because there's also a way that you can own an open source product and in this way, let's say, enforce certain directions of this product. No, we really want to support existing ecosystem and to combine this to create really a tool chain for energy system planning. And we do a lot of different stuff. We do customized software development for you if you need a need for this. We did a lot of things also now with data. That means grid data, but also demand data. We do benchmarks there. We can validate this data with you. We can do a lot of automation, how to create this data in a more efficient way. Yeah, so we do a lot of support. We do training, all those kind of stuff all around to support the ecosystem and a lot of studies, especially. So we do studies, like especially at the moment in Europe and in the US, for different system operators, regulators, very diverse set of clients. One very, I would say, interesting project we are looking into is the ACER project. We call it, it's the Agency for Cooperation of Energy Regulators here in Europe. And with them, we're doing actually a flexibility study using actually the ACER framework. This is actually closed source. So we use ACER, but this is, let's say, a model that they did not want us to make public. And I'm also not allowed to talk about this project in detail. But there will be, we will publish results at the end of 2025. But this is, let's say, one of our key projects we are working on at the moment. And I will talk you also a bit on how you can use open data and open source software even in a, let's say, secure environment where maybe information should not be released to the public, certain information should not be released to the public. So one way how we do this, but to still keep with the, let's say, open source spirit, is that our company only does soft forks. So if we fork an existing open source model, it can be actually any, or even from LF Energy, some models, we always try to do soft forks. That means we try to be always compatible with the original project so that we can merge back new developments into the original project, but also that we do not split the community. So this is, let's say, one of our core strategies that we follow, not just for this project, but for a lot of other projects. And in this way, we really want to maximize code sharing. So we can fork these projects into in a, let's say, private GitHub repository, in your personal repository, wherever. You would provide us access if you want to develop on your secure IT infrastructure. And in this way, we can really keep, let's say, your information secure, but at the same time use and, let's say, live with the open source spirit. And if you would decide on, okay, this is, let's say, some improvements we did actually to the original framework or to original model, you decide on what you really actually want to feed back into the original framework. Would be in this case, for example, ACER for the ACER study. So how this is done from a secure, let's say, IT infrastructure. So it's more or less that we have, let's say, a testing framework where our developers have access to on your machines that is secure. There, we are SSH and other secure protocols. You can, let's say, access this infrastructure, and in this way, our developers would work on your machine with your data. And we could even, let's say, if you don't want to have our developers to have access to all the data, we can switch the infrastructure to a production environment where suddenly, let's say, certain data sets that you think are very critical are then integrated into the workflow. So our developers will work on a test environment, and you just actually put a flip and it goes into a production environment to ensure that certain data is really secure from your side. And we found out that's actually, let's say, some experience is most of this work to keep it secure, the development and the modeling part is really just 20%. But most of it, let's say the work is really 80%, is really just to discussing with IT departments this secure infrastructure. So this is really a lot of work that comes with that. But let's also talk about data. Let's say we just talked about models, but we can also talk about data. Our company is also supporting a lot to release open data that is verifiable by the public to make basic information about our electrical infrastructure open. So the problem we've seen so far over the last 10, 20 years is that security through obscurity, that was also done a lot in, let's say, the energy domain, caused that certain standards had actually not, let's say, spread worldwide. There are standards in Europe, there are certain standards, let's say, that are used in the US, some of them are compatible. A lot of TSOs and DSOs have real problems actually to work with the standards because sometimes even the implementation into the standards is not that easy, and the standards are actually not sometimes being created for the energy sector. And this created, is also one reason why we have this problem with open data is just open proprietary software we're using in the past that normally also was creating a lot of proprietary input data, because for this you also had to pay, right? What we also see sometimes, and it's a huge problem, synthetic data for transmission geographic information. It's good for demand data, but if it's about, let's say, geographic information of the transmission grid, there has been a development about 5 years ago from Facebook, so that they actually created transmission grid information from night lights and other infrastructure to estimate roughly where the transmission grid goes. The problem is you don't get rid of it anymore. It's across a lot of different data sets, you still find, let's say, very strange transmission lines that are not real. Another problem is really that for a lot of countries, Africa, Latin America, and Asia, you don't find any transmission grid data at all sometimes. And if you find it, it's of a low quality. Even from official, let's say, side, this data is sometimes of low quality and does not really represent your real transmission grid. So one problem that comes with a lot of data used so far is that you cannot verify it. There's almost no chance that you know if this data is true or false. And this, let's say, security through obscurity, is how it's sometimes called, it seems to be a good idea at the beginning, right? It is critical infrastructure for our society, but I must also say it's just too big to hide, okay? You cannot hide it. And the bigger it is, the more critical it is for our society. You see here on the right-hand side is actually a transmission substation. You can see this is actually Bing imagery. So it's imagery everyone can look at on the whole globe. The same goes for Google. And a lot of the substations were actually already in Google Maps. You know, so creating yourself a transmission grid map for a country can be done, let's say, by GIS experts in 2 weeks from zero. No problem with that. By publicly available satellite data. You even don't have to buy them. So too big to hide, that's a huge problem. And that's why, actually, it sometimes shocks people, but OpenStreetMap is the only transmission grid data standard that is applicable worldwide. So that's the case. It's actually of very good quality. That I know because we started the Map Your Grid initiative, and we do a lot of transmission grid mapping, so I look at this data on a daily basis. I know it, but it's hard to prove. We are also working on proving that. And for this, let's say, to push the transmission grid mapping from around, we estimate coverage at 70% at the moment to almost 100% in 2028, we created the Map Your Grid initiative to push forward this community that is already doing this for 17 years. So there's a community out there that found a sustainable data validation and curation method for transmission grid data since 70 years. And some people think that this is actually just imports from your TSO dataset. That's not true. Because all this data, every data point is human validated. It is forbidden to upload transmission grid data in OpenStreetMap. You can put it into another layer, and then you have to validate every power tower, if you don't see it in a satellite imagery, the OpenStreetMapper does not map it. This creates actually, let's say, a very high quality of data at the end, because you always have the OpenStreetMap mapper who validates this. If someone tells you this is a substation and you look at it, and you cannot see that it is a substation, you cannot verify it, then you cannot map it. That's the rule set. So we created a lot of tooling around this, capacity building for local communities. We really, let's say, pushing forward now this community because no one supported them so far, but there was a significant amount of people who are using already this data, but there was no way to really support this community. And they even sometimes not know each other. They were just sometimes mapping together. It's a very interesting development. And I can tell you, we really see already for, let's say, everything above, let's say, 400 kilovolts, this data is globally already very good. And it's for some countries like China, the only data source you get at the moment. And you see it on the right-hand side, in some countries like Nigeria, use OpenStreetMap data for their official maps. So you see this here on the right-hand side. The problem is they don't have support to update this data on a regular basis. This is also where we support transmission grid operators. Not sometimes we see sometimes is that people are using this data, but it's also that they just copy information from OpenStreetMap in their own database. We know this for France. The France TSO regularly are in contact with actually OpenStreetMap mappers just to compare their data set with the OpenStreetMap data set to find gaps and to validate this data, because it's one of the only ways and standards how to validate your data against something differently. So, but here it also comes, we don't want to make every data about the grid open. There's one data that needs to be open. That is actually what is actually verifiable by satellite imagery. That is, where does the line goes, where are the voltages, what are the voltages, because voltages can also be measured by satellite imagery, at least the maximum operational voltage. We can see the numbers of cables at the substations. There's a lot of data that you can just inspect by satellite imagery. But when it comes to, let's say, critical data that should not be released, like maybe capacity information or loads or whatever, we also created a workflow that we just match this data based on IDs. So you would have, let's say, an OpenStreetMap data set that is publicly available, that is more or less your standard. And then you would go with actually, let's say, your client data set is closed, it doesn't want this to be public, and he will just run this on his, again, a secure and non-public IT infrastructure. We will create, we are in the moment at creating a tool called the Grid Capacity Matcher that will just match the OpenStreetMap information with your capacity information, and whoops, you have, let's say, a standard with an open standard combined with your secure data. And yeah, that's more or less how what we are working on together within Open Energy Transition with the community of OpenStreetMap. So all this tooling and all this community building, what we've done, caused really like within our team, and this must be clear, these are just, let's say, 2 people mapping. They were able to map now more than 200,000 power towers, every power tower individual set and validated, done by 36 contributors now, but let's say most of this has actually done by actually 2 mappers so far, but we now, let's say, have a lot of volunteers that also, let's say, map with us within Map Your Grid. But nevertheless, even our contributors of Map Your Grid are just, let's say, 20% of the data growth at the moment in OpenStreetMap. So most of the people who are doing transmission grid mapping are not part of Map Your Grid at the moment, to make this clear. So we are still smaller than the community. That is what I want to say. We did a lot of mapping in low to middle income countries, Colombia, Ecuador, Nigeria. We even connected the western power pool of Africa to the southern power pool of Africa. We look into all the interconnectors. We have a special methodologies and ways to find all your interconnectors, connect them, map them, give them names, connect them to Wikipedia. We connect a lot of this data to Wikipedia to also get other data sets, combine them with other data sets by IDs. And we are also mapped like in Central Asia or also in Myanmar. I'm mapping at the moment a lot just to provide and help those, let's say, local communities to actually have a transmission grid that is verifiable and can also grow and can be maintained over time. So if you're interested in that, yeah, you can map with us. It's really great tooling, but it's also great tooling to just inspect the data, and I will show this after that. So, but one thing, maybe last slide here is we also have with the Linux Foundation actually a webinar next week where we will talk about commercial grade open source software for energy planning. We do together with the Linux Foundation. It would be great if you would join, where we really also talk about how to really, let's say, scale open source approach really into globally for energy planning. Yeah, I would just give you, let's say, a short demo about Map Your Grid to give you an idea about what we are actually talking here about. Let me just, okay. This is the presentation mode. Okay, so let's go here. So this is the Map Your Grid website. And what we more or less done is multiple starter kits to really get started. If you want to just browse the data, there's Open Infrastructure Map. This is actually a representation of the global OpenStreetMap data, but it also combines the data with Russ Garrett is actually also part of our team. He's doing Open Infrastructure Map, and he's there also are included other power plants. But what is very interesting, it's also connected to a lot of other archives, like Global Energy Monitor, and this is what we really are working on. We use OpenStreetMap to combine and to link all the other data sets together. So you can get for this power plant fully automatically just the global energy information. You can get the Wikipedia article maybe for your large language model training or whatever. So a lot of data that we just combine and sync with each other and harmonize, we sometimes call it. This is here for the UK. The data is really massive, and we can just also have a look into, let's say, our tooling now. It works like this. So we have here, let's say, a lot of documentation. We actually have created around 20 strategies just to map the grid. And these strategies are very important because you have to combine, let's say, 20 methods to just get a very good representation of the grid. We can also talk about validation. We have, let's say, 10 methods to validate this. There's a huge validation pipeline on this. But let's say what I'm also very proud of is just this map it page that we created. And this is really like, you say you want, let's say, our default transmission grid data. You can also get, let's say, just really high voltage data. You can get industrial data. We can also get the distribution data. But distribution data in OpenStreetMap, no. This is because it's not verifiable. You cannot prove that on a satellite imagery that this distribution line goes in this way. So we end up always with patchy, low-quality data. But you can just click on every country and you get the transmission grid data. This takes a little bit of time. It comes about a minute. But let's look. And then it will load into your OpenStreetMap editor. It comes here. There's actually a very old program. Sometimes in open source, the oldest developments are the best. And it's also in this case. So what we see here is for Colombia, actually a transmission grid. And we are actually mapping at the moment a lot in Colombia to really create high quality data. What you see is the bubbles are the substations. You see the markers here that shows there are multiple circuits on this line. You can even, let's zoom in somewhere to give you an idea about the data quality. I forgot my mouse, so it's a little bit hard. Okay, you see here that in this case, there was actually really mapped even within the substations. That's very important for us to estimate what is actually voltage of the line. But what we also do is we validate the voltages using our voltage estimation tool, because you can measure the distances between the two phases within the substation. That's easy to do. Yeah, so that's more or less it. What we also do is really a lot of power plant mapping, because we realized, yeah, if you map the grid, you can also map power plants. They are always at the end of the line. You know, it's so easy, yes. And the interesting thing is, if you use a power plant data set, then you find new transmission lines. So it goes back and forward, back and forward. At the end, we just create a lot of power plants again. So this data is really interesting, very of high quality, but it's hard to prove the quality. And what we are at the moment trying to do is to actually use AI to, let's say, detect and redetect some of this infrastructure fully automatically, so that we can, let's say, have a more quantified way to also validate it. That's more or less it. In this case, you see, for example, what we're especially looking into are these high voltage lines. These are the purple ones. These are 500 kilowatt lines. These are, let's say, very important for this country, going through the whole. And what we really are doing is to check the numbers of circuits of this line. The numbers of circuits of a line can also be validated. You know why and how? It's actually quite easy. Let's zoom in. I still have 4 minutes. Let's see, I don't know actually where I'm here, if it works in this case. You even see here that we are mapping actually the switch base and also mapping actually the transformers, so that we know if the, let's say, line is connected from this side, then most likely it has this voltage. But you can also see here there are even proposed lines or lines under construction. This can also be mapped in OpenStreetMap. Let me go to one of the very big substations. I hope that here we go. There should be multiple circuits, and you see it in this case. One way we really validate the data sometimes in the numbers of circuits is just looking at the shadow of the power towers. You can just count the numbers of tables in it. That's actually no problem to do. One thing, and this is actually in this case not, let me just see, here you can see it. If you have multiple circuits, then you always see that at the end, actually the circuits get split up, and then it ending at 2 portals. And you can see that. That's the interesting thing. So you can calculate and validate again what's the numbers of circuits on this line. That's been done here. A lot, let's say, to be honest, a lot of this work is really also to spot power towers, but we created now within the OpenStreetMap community also the possibility to create relations between substations. So in the past, actually last years, it was necessary, if you want to connect substations, you really have to map the line. Now we just have to map parts of the line, and if something is missing in between, because sometimes satellite imagery there is just too old, we can create a relation between the substation called a circuit then, and in this way, let's say, have a plan B for where we don't have satellite imagery. What is especially the case in low to middle income countries where high quality satellite imagery that is updated is very hard to get. Yeah, so also to give you an idea, we have some multiple imagery here. This is all default OpenStreetMap. This is nothing special. We just combined this, creating this map CSS code to have a great visualization. And also, this is very important, to very fast spot problems in the grid. You can see the white lines don't have any voltages attached. You can also see that there's a gap here. It could be there's a gap because this line is under construction. So we don't know sometimes. But we normally have a lot of ways to validate and look into that. Okay, thank you so much. I hope this was insightful for you. Any questions? I don't know how much time I actually have here for questions, but let's look. So, yeah, like if you are interested actually in transmission grid mapping, it's really a lot of fun, believe me. You learn things about the transmission grid you don't know. You cannot, like, I think for some countries, I'm like really getting now an expert for the grid, because if you look at the grid and in the power plants, you really get an understanding about what are sometimes the challenges with this, let's say, special grid in which places. So sometimes people feel that this work is a little bit stupid, but it's actually not. We have now a lot of requests actually from experts that really want to also map with us, because it just gives you a very special knowledge and, let's say, perspective on this data and on the transmission grid. We also do distribution grid mapping, but we try to focus there on distribution substations, because everything else is a little bit problematic. Okay. So if there's no questions, I'm happy, like, just reach out. Yes. Yeah, for sure. Because a lot of solar power is built next to the transmission grid. So sometimes you go along the line and you see, what's that? Oh, that's like, well, that's photovoltaic, and then you map it. We just actually draw a polygon around it. That's it. And then comes someone else and says, maybe this is this name or whatever. We really just are very fast with that. But we also use, for example, we use power plant datasets like Global Energy Monitor or from Transition Zero to just find the new power plants, and we map it back into OpenStreetMap, because a lot of these detection algorithms, they use OpenStreetMap polygons for their training of AI. You know, if you like, for example, there was a wind turbine power data set globally. That's using OpenStreetMap for training data. So a lot of this data is actually used for training. There's also now, I think, Global Renewable Watch that was released by Microsoft. They said it would be open source, but it was not at the end. But they used also OpenStreetMap for all their training, because this is the best data. And you have the polygons really always around the power plant. If you want to, I can show some power plants, if there's something you're interested in. The power plants have this, let me just go somewhere. Okay. I think we have. Let me just go there. Maybe I find something here. No, I don't know. I think I have not loaded the power plant data, but it should be. Okay, this is pretty hard without a mouse. I think here we go. But we also have very simple mapping technology. So you don't have to work with this, let's say, high-end JOSM editor. But I don't find any power plant now. Okay, someone removed it for the actually the download script. We improved this, but it should be somewhere. Let me just. So power equals plant. It should work. No, it's not in this data set at the moment, but I can show you later on. Yeah. So it's also, we map actually loads at the end sometimes. We sometimes find industrial areas with a substation attached to it, then we just say, I don't care actually what this is. I just draw a line around, say, the industrial area, then I map the substation, and then we go forward. The rest does actually really the OpenStreetMap community, because they're very good in iteration. They iterate on this, and that's why this is so good data quality. Okay, another question. Yes? Yeah, we tried, and we had a huge conversation in the OpenStreetMap forum that is very long. The result is more or less, problem number one, you will not get capacity information that is with a license that is compatible with OpenStreetMap, because most of capacity data is not being released with an open data license. Problem number 2, you cannot verify the capacity of a line. You could, if you would, let's say, I don't know, but it's almost impossible to do it. So you don't know, and if there's one rule in OpenStreetMap that makes this data so interesting, things need to be verifiable by another mapper. So you can say this is this capacity, but if another mapper cannot verify that it's this capacity, the data will sooner or later just be very bad. That's why, unfortunately, the OpenStreetMap community decided on we allow to inject capacity by introducing the concept of a circuit into OpenStreetMap so that we can connect and say, actually, this is this circuit, and we can actually attach and integrate the capacity later on. But adding the capacity information into OpenStreetMap, no. Even for power plants, there is capacity for power plants in OpenStreetMap. I would recommend to use their Global Energy Monitor or other datasets. But for the geographic information, that is verifiable. Yes. Another question?
So there are many ways to control your open map, and you think there is contribute to the project, but is there also other ways to download some portion of the map into some figurable formats?
Yeah. So far, the thing is, on Open Infrastructure Map, you can download, export the data for 90 euros per country. Russ Garrett is packaging this data. But the thing is, there is so far no data standard about how to extract actually transmission grid. What is the transmission grid in OpenStreetMap? It's a huge question. We are working on that to create actually a script that defines what is actually transmission grid. But what you can actually do is, but don't tell Russ Garrett, you can here just download the data as a GeoJSON. Click, sorry, I have no mouse. Save as. And then there we go. But we also provide actually a command line tool. Open Energy Transition also provides for PipeSer workflows and PipeSer Earth workflows an OpenStreetMap extractor where you can get the transmission line, substations, and power towers if you want to. But this data set always brings you the, let's say, administrative borders and other data. But yeah, so you can actually download the data from the editor. Another question? Yeah, I'm fine. I didn't know if there's someone else coming or telling me this is now over. Okay, thank you so much.